So today we are going to start new chapter, experimental chemistry. Just remind me to share the notes of the cations and anions tests. Okay. So in experimental chemistry, first we talk about apparatuses that we are going to use in chemistry lab. We use the apparatuses to measure the time, temperature, mass, and volume. For time, we normally use stopwatch. It can be digital or analog, and the experiments that we do are not that long, so usually we record the time in seconds or in minutes. Who is Piyush? Okay. Then we have a thermometer, which is used to record the temperature, measure the temperature, and the scale in which the unit in which we record is Celsius or Kelvin. Then we have a weighing balance or balance to record the mass, and we usually record it in grams or milligrams. We have not that much bigger mass, so we don't have to measure it in kgs. Note it down quickly. Assalamualaikum Abdul Sami.
Walaikum salam, sir.
Why you are not joining?
Yes, sir.
You were not joining the previous classes.
So because of test, my test was failed.
And Piyush, is this your first class, right?
What's it?
No, I am talking to Piyush. Is everybody noted down? Okay, so then, okay. Then to record the volume or to measure the volume, we have a different apparatuses. Out of these, one is burette. We use burette to record the volume or measure the volume of liquid, and we will record the volume accurately. If you see the burette over here, you can see there is a graduated scale over here, right? And here it is a tab. So we can control the volume and we can add the volume how much we want to add from the range of 0.1 centimeter cube till 50 centimeter cube. If I want to add 11.1 centimeter cube, for example, so I can easily add it from 0 till 11.1, and there I will stop from the tab. Okay. So normally burettes have a maximum capacity of 50 centimeter cube, and we can record any volume or we can measure any volume from 0.1 till 50. The another apparatus is volumetric pipette, or we also call it pipette. It is also used for measuring the volume accurately. But the difference between burette and the pipette is this. If you see over here, it's a pipette. Are you observing any tap over here?
No.
No. And are you observing any scale? There is no scale neither, right? And if you see, there is only one mark over here. And if you see the capacity, it is telling me that it is 25 centimeter cube or 25 ml. So from burette, I can add or I can record the volume accurately, but I can just record 25 only. I cannot record any other volume beside that 25 from the pipette. But from the burette, as you can see, there is a complete scale. So we can record the volume from 0 till 50. In between, any volume can be recorded or measured through the pipette. But through the burette, only one exact volume can be recorded. Is the difference understandable to all of you? Okay. Another thing is that how can you fill the burette? Yeah. Otherwise, if it's not there, then it will work like a straw. So we will put it in the solution and suck from the other side. But sometimes we usually fill acids with it. So there is a precautionary measure if we do it in that way, then sometimes that liquid can enter our mouth. So for the safety precautions, we will use safety bulb, which is seen over here, or it is a pipette filler. So we can use them to fill the pipette with them. Okay, so this is the reason that is normally asked by the examiner in paper 4. Okay, so now note these two apparatuses down, then we will discuss the other apparatuses.
सर हम जब क्या लिखते हैं ब्यूरो के आगे फॉर वॉल्यूम ऑफ
Liquids.
Sir, I have a question.
Yes, Khatija.
Sir, I was asking that in burette, is it possible that 2 decimal places value can also be measured?
In burette, we can record the volume till 1 decimal place. For example, if I have to record the volume, if I have to measure the volume like 19.5 centimeter cube, so I can do it with the burette. Is this understandable?
Okay. It means we can only measure till 1 decimal place, right?
Yeah, till 0.1 decimal place, we can measure it till 0.1 centimeter cube.
Okay.
Okay, the accuracy of both pipette and burette is same, but the only difference is that I have told you earlier, from the pipette, we can add only exact volume. But from the burette, we can record or measure the range of a volume. Yes. That safety belt and pipette flare both are used to fill the liquid or solution in the pipette. This can avoid solution entering the mouth. Yes, everyone completed? Mr. Rohan, how much left? Are you done?
सर ये जो पॉइंट लिखा हुआ है अदर वॉल्यूम कैपेसिटी इसका क्या मीनिंग?
It means that this pipette is of 25 centimeter cube, as you can see in the diagram. So there are some other pipettes like 5 centimeter cube capacity or 10 centimeter cube capacity. So from that pipette, we can only transfer that 5 centimeter cube only or 10 centimeter cube only, whatever the capacity it has. Okay.
Yes.
Okay. Now, next we have a measuring cylinder. It is used for measuring the volume of liquids and it is used for approximate measurements. Gas cylinders are accurately measure the volumes of gases. Then we have a conical flask, which usually used in the experiments like titration. Besides this, there is a scale on the conical flask as well, if you can see over here. So that scale also, records the volume at approximately, not accurately. So let me write over here. Approximate measurements. Experimental chemistry. You guys are solid. Who told you? Every time we have a class at 4. And you also not there on Saturday's class.
I didn't want to.
You are not in the group.
Yeah, I didn't. Please don't say anything. They on.
Sir, I have a question.
Yes.
That if multiple ranges are given of the volume, so how we will identify that with which apparatus we will use?
Okay, so you got to know that normally pipette, you have seen that it's 25 centimeter cube. So if you have to record exactly 25 centimeter cube volume, you use pipette. If you have to measure any other volume accurately, then you can use burette. And if you have to record or measure any volume approximately, then you are going to use measuring cylinder. If you have to perform titration, we will perform titration in conical flask, and you have to record the volume of a gas, then we will use gas syringe.
Okay, sir.
Everybody completed till here? Yes, after the class. I will share it in the group as well. Okay, now volumetric flask. If you see, volumetric flask looks like this. There is a one mark over here, and basically this mark and the volume written over here tell you the capacity of this volumetric flask till this mark. Okay, so where we use volumetric flask, it is normally used to prepare solutions, and when we need to dilute the solution, for example, we have a stock solution which have a very high concentration of acid, and from that high concentration of acid we have to make a one dilute solution of acid. So we will take some amount of that acid into this measuring flask, volumetric flask, then we add the water till this mark to prepare the solution. Okay, so it is, remember, whenever we have to make the solution or whenever we have to do the dilution, we always going to use volumetric flask. And they also have are of different capacities. Then we have a beaker. Beaker is also used in experiments where we mix two or more chemicals and allow them to react. And beside this, if you see on the beaker, there is a scale as well, right? So that scale, again, see here, it is written as well, it's approx. So beaker, beaker, conical flask, and measuring cylinders. These three always record or measure the volume approximately. These are not going to give you the exact or the accurate readings. Exact and accurate readings are taken by pipette, burette, and that volumetric flask. So it also do approximate measurement or approximate volume of solution can be measured. And I think there is no need to explain the test tube. Everybody knows what is test tube. We just do the chemical reaction unit. There is no graduation or there is no scale on the test tube for the measurements. So the name of these apparatuses are very important. Sometimes examiner give you the different pictures and you have to identify, label the apparatuses. So normally students got confused in volumetric flask and the conical flask. I think beside these two, rest of the apparatuses are much familiar. Is everyone done?
Yes, sir.
Now we have experimental design. So you need to get familiar with few terms before we are going to discuss experimental design to separate different substances. Okay. So first one is a solubility. Solubility means that the solubility will tell you that how much solute can be dissolved in a specific amount of a solvent. For example, if I say the solubility of, let's suppose, it's an example that the solubility of sodium chloride is 10 gram per 100 ml. So it means if I have 100 ml or 100 centimeter cube of a water, in that 100 centimeter cube, I can dissolve 10 gram sodium chloride. If I try to dissolve more than that 10 gram, then it cannot be dissolved. Only 10 gram gets dissolved. So that is the solubility. So solubility tells us the capacity that how much a solvent can hold a solute in it. Difference between solvent and solute, I think everyone knows solvent is a substance in which we dissolve the solute. So normally an example of a solvent is water, because in water we can dissolve sugar, in water we can dissolve salt, right? So many things can be dissolved in water. So water is a solvent. So solvent is a substance which is always in a larger amount in a solution. The other substances, so, or the component is solute. So solute is the one which dissolved in water or which dissolved in solvent, basically. So you can say salt, water, sugar, all are considered as solute. And solutes are the smaller parts of the substance of the solution. They are always in the smaller quantity. Then what is solution? Solution is a mixture of two or more substances, and those two or more substances are, one is a solvent in which the things get dissolved. Then saturated solution. So saturated solution is the one in which maximum capacity of solute is present. If we add more solute in it and stir it, try to dissolve it. So if no more solute is getting dissolved in it, then it means that is a saturated solution. Unsaturated solution, it is the solution which have a capacity to dissolve more solute in it. For example, if I have a one solution of a sugar, and if I add more sugar and dissolve it, and on stirring it gets dissolved, so it means that initially the solution is unsaturated because it have a ability to dissolve more solute in it. So saturated is the one which cannot dissolve any more solute in it, which have filled with its maximum capacity of solute. The maximum capacity of solute is actually dissolved in it. And the unsaturated is the one which have a capacity to dissolve more solute in it. Then concentrated and diluted. These two are the relative terms. When we use the term concentrated, it means that in this solution, there are relatively more particles of solute. For example, if I have a 2 glass of water, and in 1 glass of water, I add 3 spoons of sugar and dissolve it. And in the other glass, I have added only 1 spoon of sugar and dissolved it. So the solution which is prepared by 3 spoons of sugar is considered as concentrated solution. And the one which is prepared as by 1 spoon is considered as a diluted solution. But now another thing over here. Now I take another glass and I put, instead of 3-4 spoons of sugar and dissolve it. So now the one which have a 3 spoons becomes or considers diluted solution when I compared it with the one which have a 4 spoons sugar in it. So these concentrated and diluted are the relative term. We use the term concentrated and diluted when we are comparing the two solutions, and concentrated always means that it have a more solute in it, and the diluted is the one which have a lesser amount of solute in it. All these terms understandable to all of you? If any one of you have any query, please ask. Okay. Then note these down. Okay.
Sir, can we say that saturated and solubility is the same thing?
Sorry.
Can we say that saturated solution and solubility is the same thing?
Uh, yes, in some aspect, we can say it that uh, basically, you can say that solubility depends upon saturated solution depends on solubility.
Okay, sir.
Okay. Then we have two more terms. One is called residue and the other one is called filtrate. For example, we have one solution, and in that solution, we have some solid in it. So when we do the filtration, for example, let's have a look. This is a funnel, and here I have a container, and from here I am adding a mixture of a liquid and solid. So after the filtration, what will happen? All the solution collected over here, and the solid is collected in the filter paper over here. So that solid which is collected or which is separated from the solution, that solid is called residue, and the solution which comes out of the filtration after separation, that solution is called filtrate. Okay, is this understandable?
Yes, sir.
We evaporate, solvent evaporates, and if we get a solid left behind, that solid is called residue. For example, you take a seawater. When you evaporate when you heat it, water will be evaporated, and in the container there is a solid salt left behind. So that solid salt is called residue. Is everyone noted down the names on that page? Where is the page? Yeah, pen. Pen they were substituted.
Sir, the solution could be soluble or insoluble also, right?
Can you repeat, please?
Yeah, the solution contains the solution can be soluble or insoluble as well, right?
Insoluble, we normally call it mixture. If the solid is not
Okay.
dissolved, then we call it mixture. We can't, if the something gets dissolved, then we call it solution.
Okay, sir.
This 16. Residue is a solid. For example, when we do the filtration to remove the solid from the solution, so the solid that we got on the filter paper is residue. For example, if you evaporate, if you heat the seawater, so what will happen? All the water gets evaporated, the leftover solid, the salt is called residue. Is everybody completed till here?
Yes, sir.
Then now we are going to discuss the methods of separation and purification. When we talk about mixture, so mixture is a impure substance. Okay, mixture can be a solution like seawater or like mineral water is also a mixture. Okay, and mixture. Okay, it's not necessary that every time mixture have a liquid in it. Sometimes, there are two solids as well. For example, if a sand is mixed with the iron fillings, then it is also a mixture. Okay, so to make the things pure or to separate the components of the mixture, what we will do, we will use a separation and the purification techniques. So there are few purification and the separation techniques that are included in our syllabus, out of which one is filtration, second one is crystallization, third one is simple distillation, then we have a fractional distillation, and another one is using suitable solvent. Beside these, there is one other technique which is called chromatography. Okay, so these are the techniques that we perform to separate the components of the mixture and make the substance pure. So filtration is a very simple technique, and we will always do it when we have to separate a solid and a liquid. So whenever we have to separate the solid from the liquid and an insoluble solid, then what we will do, we will perform a filtration. When we do crystallization, what is the purpose of crystallization? Okay. So it means we do crystallization for a solid which is water soluble and it is actually dissolved in it. So why don't we do evaporation? Because when we evaporate the whole solvent, then the left behind is the solid. So why we do not do evaporation and why we perform crystallization?
Because we want the clear crystals of that solid.
So that crystals can also be left behind when we evaporate the whole solvent. No. Actually, when we do the evaporation and when we heat the solution till evaporation, so what will happen? That all the solvent will be evaporated and it needs a higher temperature. And there is a risk that at higher temperature, sometimes the substance, the solid that we need might decompose and broken down into some simpler substances. So that's why we always avoid evaporation and instead we do crystallization. Because in crystallization, we do not need a very high temperature. So if we have to obtain crystals of a soluble salt from the solution, then we will perform crystallization. These are the 4 steps for the crystallization. We heat the solution, but we do not heat the solution till dryness. Instead, we heat the solution and we observe the solution. What happens when we heat the solution? Solvent starts to evaporate. When the quantity of the solvent decreases, then as a result, some of the dissolved particles forms crystals and they are at the bottom the crystals appears. So that is called crystallization point. So we heat it and we heat until we observe the crystals at the bottom. When we see that the crystals are formed, we stop heating. Then we leave it for cooling. As it cools, the temperature gets lower, and as the temperature goes down, the solubility also decreases. So more dissolved solid turns into crystals, and at room temperature, we will get plenty of the crystals. Then we have filtered those crystals, and then by the help of filter paper or by oven, we dry those crystals.
The dry is gonna punish washing.
So they are water soluble, right? So if you wash it, water it drains away, it gets dissolved in the solution. We do that when we have a solid which is water insoluble. So for water soluble solid, yeah, we can wash it with the organic solvent. But we do not wash those crystals because they are coming out of water. If we wash it with water, it again dissolves in the. So we are keeping the class till here for today. And another very important